In this video, we will factor 9x squared minus 16xy minus 4y squared. The first step in factoring any polynomial is to look for and factor out a greatest common factor. When we look at the variables on the three terms, one term has an x squared, the other has an xy, and the third has a y squared. There is no common variable through every term, so there is no variable component to the GCF. When we look at the coefficients, we have 9, 16, and 4. There is no factor of 9 that is common to 16 or 4 other than 1, making our greatest common factor 1. Since there is nothing to worry about with a greatest common factor, we then look at the first term and hopefully recognize we have a 9x squared. Because that is a 9 and not a 1, we're going to choose to use the AC method. The AC method takes the a value, the 9 from the 9x squared, and the c value, the negative 4 from the negative 4y squared, and multiplies them. So a times c is 9 times negative 4, which is negative 36. So we need to find something that multiplies to make negative 6 and adds to make the b value, negative 16. We'll do this by constructing a table of factor pairs for negative 36. The first column will have the factor pairs, the second column will then have the sum of those factor pairs. Before we write down the factor pairs of 36, we need to stop and think about the signs. To have two numbers that multiply to make negative 36, one number will have to be positive and one number will have to be negative. The second piece is, to add to make the b value of negative 16, the larger number will have to be negative. So when we write down these factor pairs, we'll make sure the larger number is the negative one. So now looking for things that multiply to make negative 36. 1 times negative 36 is negative 36, and 1 plus negative 36 is negative 35. That gives us the product we needed, but not the sum. 2 times negative 18 is negative 36, and 2 plus negative 18 is negative 16. That is the pair that we needed. There are other factor pairs of negative 36, but we found the one that we need. To make use of this factor pair 2 and negative 18, we will return back to the trinomial that we started with, and we will take that middle term, that negative 16xy, and we will break it apart into a positive 2xy and a negative 18xy. The rest of the trinomial will stay the same. So we'll now have 9x squared plus 2xy minus 18xy minus 4y squared. It's important to recognize and check if we were to recombine those two middle terms. They are like terms, and they would combine back to give us negative 16xy. At this point, we now have 4 terms, and so we're no longer thinking of this as a trinomial, but instead a larger polynomial. And the method we have for factoring larger polynomials is grouping. We will group the first 2 terms together, we will group the last 2 terms together, and make sure that there is addition explicitly between the 2 groups. So our polynomial now looks like, in one group, 9x squared plus 2xy plus, in another set of parentheses, negative 18xy minus 4y squared. In the first group of 9x squared plus 2xy, there is a common factor of x. And if we factor x out of that group, we will be left with 9x plus 2y. In the second group, negative 18xy minus 4y squared, I recognize 2 things. Both the numbers are negative, so we'll factor out a negative, and both the numbers are even, so we'll actually factor out a negative 2y. Factoring out negative 2y from negative 18xy minus 4y squared gives us 9x plus 2y. The hint that we are on the right track is that both groups individually factored, and now both groups have a common factor of 9x plus 2y. So the final step in factoring by grouping is to factor that common 9x plus 2y off, and to put in the back set of parentheses the remaining factors, x and minus 2y. So our factored version of this polynomial is quantity 9x plus 2y times the quantity x minus 2y. It is important to point out that while it is not explicitly asked for in this exercise, you should always take a moment and check your work. Redistribute the factored version to confirm that you do get back to the original polynomial that we had started with.